Hi, I'm Mark Grandusky. I'm the product sales manager for the G-Force Intelligent Lift Device product line for Gorbel. So the whole idea of an intelligent assist device or an intelligent lift device is movement that tracks with natural human motion. No buttons, no throttles or anything else to push to have to control the unit. Now on this particular unit, the G-Force, you'll notice we have a very ergonomic lift, or ergonomic grip here. So when I grab onto it, I have a grip that is very ergonomically tailored. It's got a nice rounded portion in the center, fits my hand nicely, fits the curvature of my palm, has nice flared features on the top and bottom for comfort, and also you'll notice the little dimples in the grip there are to reduce contact pressure. In addition to the redesigned Estop, to reduce the potential for damage to the E-stop, and now we have the die-cast aluminum housing of the unit. We also have this very durable rubber bumper here, so that if the unit actually takes any kind of impact to the side or front, everything is very well protected and it's going to last a long time. If I turn this around to the back of the handle, you'll notice on the back side of the grip there's this little indent here that there's actually a sensor, a photo sensor in here. Now the operator would typically not even be aware that this feature exists, but the purpose of it is when I grab onto it and my hand breaks that sensor beam, it activates the unit and the unit moves up and down. If I don't have my hand on it, it's a safety feature. It will not move unless the operator is positively engaged on that handle. So the load itself is in a braked condition, and even if I bump or move this handle, it will not move until I physically grab onto the handle, and then it will move. I also want to talk about the E-stop feature here. This red button is the E-stop for the unit. Simply pushing this in will shut the G-Force down. Giving it a quarter twist to the right will actually bring it back up. Also notice that it's well protected. We've got a little bit of an overhang up here and it's at an angle, so if you actually come up and impact this E-stop button, the worst that's going to happen is it will maybe shut off, but it will not be damaged. Another feature of the G-Force, and a very important feature in many applications, is what we call float mode. Float mode, this button over here, if I press this button, you'll notice a little blue light will light up on the unit, and that indicates I'm in float mode. Now instead of having my hand on the handle itself to move it, it gives me positive control of the load itself. Now this will let me move up and down with positive control of the load itself. So this is very important if I'm going to be positioning this or placing this in a very specific point. For instance, if I'm going to a production line and I have to get on some locating pins on an engine assembly or a transmission assembly, this is actually very useful also if I'm orienting something on a horizontally oriented spindle or bolt pattern. So if I needed to move this up and down and actually place it onto a spindle or line up some bolt holes, this is a very, very useful feature for that. So you'll notice again, fingertip force, fingertip control up or down, and again up to 660 pounds or 300 kilograms with this product line. In addition to the basic functions, when I talk about the Q and the IQ model, so the basic functions of the Q model are the up-down motion with the human operator and the float mode that I just demonstrated. Those two features are available across the board with any of our Q or IQ models. One of the very unique features that differentiates the Gorbel lift device from really any traditional lifting device that has this coil cord assembly on it is the presence of this air and electric collector or swivel. What this allows me to do is actually spin the load below this point, or spin the load and the handle below this point. Now in an actual application where an operator is using this, if the operator would tend to lift and pick up the load and set the load back down and then continue in 360-degree motion and continue to do that, what ends up happening with any device that has any kind of a coil cord like this is it gets very tangled up, and it's a maintenance issue. It can result in downtime, increased maintenance costs. What this will allow you to do now is no longer damage this coil cord because of continuously rotating. Now you don't have to rely on the operators using the device properly to prevent maintenance issues. This simply is going to take care of that for you. Okay, with the swivel assembly, again, it does carry both electric and air signal all the way through this swivel point here. And the way that will happen is this connection right here is our connection for the coil cord to bring all the signals that operate the G-Force, as well as input-output signals, which we'll talk about in a little bit, through this connect right here. And the Q and IQ unit both have a CAN bus interface, which is a simple two-wire data stream that will run back in here, which allows you to put quite a bit of input and output on the tool itself and carry it back through the swivel point on a 2-wire feed. That connection point will be right here, and then for the air, if you have an air-powered end effector or any kind of air need below the swivel point, you actually would come over to this port right here, pipe your air into that port, and then that will also carry through the swivel assembly and come out right here at this air connection. All right, one of the features that's really nice about the G-Force here is the ability to have this LCD here that gives a lot of communication back to the operator, and it also allows for a whole lot to be done right here at the handle level, not having to climb up into to get to the unit to adjust certain things. For example, speed changes. If you wanted to actually tame the speed down a little bit to be a little slower, you could actually go in here, and by pressing this button, we go into a program mode. When I go into program mode, I can select different menus. I just selected the speed menu, and you'll see it shows it 100% speed right now. And going through here, toggling through this menu, I can change in 10% increments from 100% all the way down to 10% or back up. So what I'll do here is change it back to 100%, but that's really nice. Now, on a lot of other units, you would have to actually get on the ladder, get up into the overhead, either plug in with a computer or use a screwdriver or some other tool to actually change that speed setting. Another nice feature, again, we're differentiating between the Q and the IQ units. The IQ unit comes standard with what we call virtual limits. Now you'll notice right now if I go up and down with this handle, I've got full range of motion through the up and down stroke. I can go all the way to the floor, and I can go all the way to the full upward limit. But I have a menu in here that I can go into. Looking at my LCD again, you'll see I've got, going to program mode, my first menu, it says VL menu. That's virtual limit. What I can do there, I can actually set a point, and what I'll do first off here is set a slower down or a slow down point in the lower directions. What that's going to do for me, I just set a point in the stroke that it's going to slow down to a slower speed. So it'll go high speed to the point that I just set, and then it'll automatically go to a slower speed. One of the things that this is very beneficial for, if the operator is going to be setting this product down, and say this is a very fragile part, they'll be able to set it down and automatically go to a slow speed, so they cannot actually damage the part by setting it down. So now you can see I can come down full speed again, which is about 60 feet a minute, and as soon as I get to that point, it automatically slows down. I cannot go any faster than that speed right there through the rest of the stroke. Still talking about virtual limits here, we also have the ability to set hard upper and lower virtual limits. Now, one of the things you might want to set an upper limit, a hard upper limit for is, say, ergonomically, you don't want the operator lifting above shoulder level, and so you can actually tailor this for a certain operator's ergonomic position. So say you don't want the operator lifting above shoulder level, you could simply go into this unit, go into the virtual limit program menu, and toggle through until you see upper limit appear. Let it sit there, it'll blink several times. Now that upper limit is set right there at that point that I just set it at. Now I can come to that point in the stroke and never any higher than that. So in addition to the speed, I can also tailor my acceleration. Currently it's set at high, but I can set a low, medium, or high acceleration. One of the benefits of that is if you have it on a structure overhead, say on a long bridge, and you have a little bit of deflection in the center, you can actually reduce the amount of impact that this unit will put into the bridge and minimize the bounce of the bridge. In addition to all the other information you can get with the LCD, we also have, if you notice, you have a weight readout. That weight readout actually comes with, when you add the float mode option, the float mode responds from a load cell that's added to the unit, and that load cell can be read out in the form of a weight readout that's available here on the LCD. So whenever you pick a part up, when I grab onto it, you'll see it'll actually move up and down. As soon as I stop moving and let my hand off, it will switch over and it will show you the weight of the product itself. Now what we've got here also with the LCD is the ability to have some service information from the unit. Now when I go in here in the program or in the menu mode, I'll toggle through to a menu for service, and this is a service menu, and what I'll do is toggle through the service menu till I get a display system info. When I display some system info, you'll see you're going to get a on time, run time, and cycle count. So what you'll see, the on time is actually the amount of time power has been applied to the unit. The run time is the actual amount of time the unit is actually being used lifting, and the cycle count is actually the number of cycles that the unit has actually gone through with the operator using it. Okay, we're going to talk about the capacity overload feature. This feature of the G-force can actually sense when it's got an overcapacity load and will not allow the unit to lift beyond what it's rated for. So you'll see when I grab onto this, I'm going to lift a load that's beyond 300 kilograms. As soon as I lift up, you will notice the red light starts to flash and it tells me that I have a capacity overload. At this point, I cannot travel upward any further. It inhibits any upward motion. It will allow me to travel downward until the load is actually unloaded, and you can see now we're unloaded. Once I let go of the handle, all I need to do then is re-grab the handle again, and I can start all over again. But yet again, as soon as I lift up that load, it will sense the overcapacity condition and stop the unit. Okay, talking about a very important safety feature of the G-force is the fact that it will not recoil under loss of load. Now with types of traditional lifting devices such as air balancers or vacuum tube lifters that counterbalance the weight of the load with air pressure or vacuum pressure, those devices will recoil. If you lose a load, they will recoil upward and cause potential injury to the operator or potential damage to the product being lifted. So with the G-force, even though an operator holds the handle active, and so the G-force is actually lifting the product, I can come in here and lift off the 75-pound load, and I can put it back on, and that change in load does not affect the position. So the G-force will never recoil under a loss of load. Again, that's a big safety advantage over traditional lifting devices that use air or vacuum to compensate for the load. All right, we're talking about another important safety feature of the G-force is what happens when you lose power. The G-force will actually come to a complete stop, and a fail-safe brake will set if power is lost, and no motion will be able to happen until power comes back up again. So to demonstrate this, I'm going to lift this up. I'm going to get a good running start coming downward, and then my colleague here is going to disconnect the power, and you'll see exactly what happens. And that's exactly what happens when any kind of power loss condition occurs. Again, very safe. This will not move at all. A fail-safe brake is in place and will stay that way until power comes back. In summary, the G-force product line breaks down into two different models, the Q model and the IQ model. And with the IQ model being the higher intelligence of the two and offering features over and above the base features of the Q model. And overall, the G-force product line is going to bring you higher productivity in the form of the speed, product damage reduction in the form of the precision lifting, and a lot more flexibility beyond what you're going to get with any intelligent lift device on the market today or any traditional lifting device.